I don't know if you noticed, but the liters will cancel the liters in the denominator. The unit for liters is now canceled. So liter divided by liter, they cancel each other out. So liters cancel each other out. So it's 67 times that. And we're left with 78.99. And then here, we need to round off to 2 decimal places. Okay, so that's that piece. So far so good? That was not bad, right? This is how much gas I need. This is how much it costs per liter. You multiply them. Okay, example number 2. Let's go to example number 2. While filling your tank, you take an odometer reading. Okay, well, pause for a second. What is an odometer?
Take your mileage.
Mm-hmm. Yeah, that's a number.
Distance traveled.
The distance traveled, the mileage, right? Yeah, that's what the odometer is. It's on your dashboard. At the previous gas station, your odometer read, your odometer had a reading. Oh, maybe just get rid of your odometer had a reading of 21,747.3 kilometers. And then now it's 22,453.2 kilometers. How far have we driven from the last gas station? So how far have we driven from the last gas station? So what can we do for that?
999 subtract 747.
We could subtract the old odometer, the new odometer reading, minus the old one, right? So new odometer reading minus the old one. That's how far we've traveled since we had our last fill. So the distance traveled, okay, so it's 22,453.2 minus 21,747.3. Okay, so let's go ahead and calculate that piece. Did you get 705.9? Yeah? So 705.9. What's our unit here? Kilometers. Yeah, that's a distance. Well, that's a lot of kilometers for one full tank of gas. Yeah. Anybody here drives right now? Who's driving? You do drive? Okay. You do? Yeah. You drive a lot. Okay.
I do that all the time.
Okay, you drive. Okay, good. Then you understand how the vehicle finance goes, right? Okay, that's awesome. My car only goes up to like about 400 kilometers for a fill. This one is actually big tank. So, okay, before I move on to the next part, it says here, if you know the distance driven in your car, okay, which we actually could figure out from the new minus the old kilometer reading and how much fuel was used, we can determine our vehicle's fuel economy. Okay, what's a fuel economy? What is this? What's a fuel economy? Fuel economy is defined as the number of liters of gas required to travel 100 kilometers. So that's what a fuel economy is. How much gas need to travel 100 kilometers. So if you want, you could put that on your study sheet or highlight this now so that we know for next time. Okay, so fuel economy is defined as the number of liters. So how many liters do we need to travel 100-kilometer distance? Now, the smaller the number, the less gas it takes to travel 100 kilometer. Therefore, the better fuel economy. So in this case, the lower the number is better. Okay, because some people think the higher the number is better. No, lower is better because we use less gas to travel 100 kilometers. So vehicles with better fuel economy will use less gas. If it uses less gas, it will also save us money. So that's a great thing. Good. Any questions or comments, or so far it's okay? Let's go to the next page. Page 2. Page 2. When choosing a new car to purchase, okay, when choosing a new car to purchase, the seller should provide you with kind of an estimate of car's fuel economy. And this is like for the new car, okay? If you've gone to like a dealership with a brand new car, you'll probably see some specification of the car. And one of the information there is a fuel economy. So this particular one is, as you can see here, fuel consumption. That's a fuel economy. Actually kind of obvious because there's a fuel thing, pump over there. How much does it use? It uses 9.0 liters per 100 kilometer. Now, over here, but that's a combined one. Do you notice something here? I'm gonna hope I
That's
don't.
an average.
Average, yeah, combined. Okay. Yeah. So combined. Do we notice something in here? City driving will use 10.7 liters per 100 kilometer. And then a highway driving is 7.4. So the fuel economy, how much fuel we use, depends on where we drive, right? The city would be 10.7, slightly higher. And then in the highway, it's 7.4, which is slightly lower. Now, let's think about why would that be? Oh, this is another thing here. Annual fuel cost. Annual fuel cost, it's going to cost us every year $1,960. But that's if the average fuel is $1.09 per liter. Okay, so it's gonna be more only because our price of gas is like $1.13, $1.14. Okay, good. Okay, says here, notice that the fuel economy is also known as a fuel consumption is 9.0 liters per 100 kilometers. It means that every time we drive 100 kilometers, it will use 9 liters. That's what it means. At about $1 a liter, it will cost you about $1. At about $1 per liter, it will cost you $9 for every 100 kilometers. So we'll talk about the calculation later. Obviously, you would like to use less fuel, right? Because it's good for your pocket and it's good for your environment, our environment. So the car with the lower fuel economy would be better. So, can you, are you familiar with like a hybrid? Have you heard of that one? Hybrid? Yeah, so it's like a plug-in car, half plug-in car, and then sometimes it uses.
It's like the car that Brian drives on Family Guy, right? Hybrid. Is that the car?
I'm not sure. Family Guy?
Yeah.
Maybe. Now I'm curious. I gotta watch it. I'm not sure. Anybody knows?
That would be like what the cabbies drive here in the city, right?
Yeah, sometimes. Yeah,
Yes,
it's a hybrid, right? Yeah. It's like a Prius, right? It says hybrid at the back.
Yeah, a Prius. That's what he does.
A Prius, yeah.
A Prius.
So it would probably use less gas because it's more. And there's one that my neighbor has this electric car. So they just plug it in, and because it's electric, the more you drive, it recharges the battery, and the more you drive, the better it gets because you can get more mileage from it. But his is a fancy car.
I thought it should be, the battery would be lower.
Yeah. So, but
Same like phone, we use phone more, even the batteries go up.
yeah, but this one here for some cars, like I said, my neighbor, the battery gets lower, but can charge it. He can plug it in to get charged, so he doesn't go to the gas station as much. Which is
But
kind of
if they
nice.
don't then plug in, they have to be low.
Hmm?
You can start if they don't plug in.
Yeah. Well,
No.
yeah, it still has gas, okay? So it's not just completely electric. It still has gas. It's just that it will use more electricity. So it costs less money for sure, and it's good for environment. Okay, so it says here, examine the fuel economy sticker above. Okay, we did, and it says here, it lists a city fuel economy. So if we drive in a city, it's gonna be 10.7 liters per 100 kilometer. And in the highway, it's 7.4 liters. State a reason why a vehicle would have a better fuel economy when driving in a highway.
Idling on red lights. Idling.
Idling, yeah. So, yeah, in city, there are a lot of idling. Idling, like when you're not going, you're just kind of parked, right? That one uses when every time you stop and go, it actually uses more fuel. Stop and go motion. Okay. Which uses more fuel. Okay. So in the city, there are a lot of idling and the stop and go, which this is W, which uses more fuel. Okay. So far so good. So that is a reason why it's not a constant, and maybe some of you or all of you are familiar with the cruise control. Yeah? Okay, so some people are nodding. Cruise control. It's a feature where it's that your car just travels in a constant speed, and it's not increasing in speed, it's not accelerating or decelerating, because that one
Not revving the
consumes.
engine.
Yeah, and you're not revving the engine. Correct, right. Because the revving the engine is where it uses more. Yeah, that's right. You know a lot about the cars, right? Sounds good. Huh?
just good for the highway.
It's good for the highway, yeah, certainly. It's good in terms of fuel
But
economy.
if I need to be in at night time, it's not good. It's good only for the day. Because in case if there is anything like a deer and you put the car in the cruise, then the car will not control.
Oh, you mean like the cruise control? Yeah. Yeah. Yeah, no, definitely. You wouldn't do that at nighttime for sure. So you are looking, let's take a look at example number 4. You're looking at three different cars. They have a fuel economy listed below. Which car has the best fuel economy? Which car has the best fuel economy? Is it car A? It has an 8.3 liters per 100 kilometer. Or is it uses 9.2 liters to travel 100 kilometers, or the 7.8 liter? Which one has the best one?
Then the sea,
The C, yeah. Yeah, because it only, C, because it only uses 7.8 liters to travel, because they're all the same 100 kilometers, but this one uses the least amount of fuel. Okay, that's good. So far it's okay. Let's take a look at example 5. Now, we're going to start to do some other calculation here. If you know the fuel economy of the car, you can predict how much gas it will use in liters to drive a certain distance. It is important to remember that this is just a prediction, approximation. Actual fuel economy will vary according to the driving conditions, how the driver decides to drive. You know, like sometimes when people are stopping and going all the time, some people at the stoplight, instead of a gradual, I don't know if you've seen that, maybe some drivers after the stoplight, they like drive off really, really fast from 0 to like 60 kilometers per hour, and right? That one uses a lot of gas. But if you're to stop and then you are more gradual, slowly increasing your speed, that one uses less gas. So when you do that, yeah, kind of ease in a bit. Example 5, using the fuel economy. You're looking to purchase a used car. Okay, you found a 2016 Honda Civic that you like, but before you buy it, you want to check the fuel economy. You look online. Okay, so yeah, if we have a chance, we can take a look at this one, see if it's still there. So you see that the fuel economy for this vehicle is 6.7 liters per 100 kilometer. That means it uses 6.7 liters of gas every time they travel 100 kilometers. Letter A, you drive on average 2,100 kilometers a month. On average, so it's not exactly like that, so approximately. Use the fuel economy to determine the approximate number of liters of fuel that you will need to purchase each month. So how much will it cost, the fuel, each month? So, how do we do that?
liters.
140 liters.
Yes.
You're guessing? That's a pretty good guess. Yes? Okay. How did you do that? How did you do that?
6.7 times 21 divided by 100.
Okay. Good. I'll show you. Is that what you did too, Joel? Yeah. So 6.7 times 2100 divided by 100. Okay. So I'm going to show you a step by step on how to do that. Okay, that's pretty good. Here we go. So I know the fuel economy is 6.7 liters per 100 kilometers. Okay. We know that it's 6.7 liters per 100 kilometers. I'm going to look at it in a different approach so that it's very systematic. So if you want to follow this way, you could. And we know that the average is 2,100 kilometers. So this is kilometers in the denominator. So I'm going to put that 2,100 kilometers in the numerator. Okay. So what do we need to do? Oh, very nice. Yeah, okay, good. So 100 kilometer, are you gonna use more liters or less liters? Well, already somebody said 140, so it's gonna be more, right? So you have more kilometers, so that means you're gonna need more liters. So I like what you guys remembered about cross multiplication. Okay. So cross multiplication, you take this and multiplies with that. So I'm gonna go X is the amount of fuel that you need. So it's 2,100 times 6.7 divided by 100. So go ahead and do that. You said 400 and yeah, 410. Oh, sorry, 140. 140. 0.7. Sorry. 140.7. What would it be? Liters. Yeah. Liters. So to travel at 2,100 kilometers, it's gonna use up 140.7 liters. Well, how much is that gonna be? Yeah. Okay. So if that's a good one, right? Because that's a B. The B says if the average cost is $1.15 per liter, calculate the monthly expense. So 140.7 liters times it by $1.15 per. Okay, remember the line there means per liter. The unit liter cancels. Oh, it's gonna cost us $161. Okay, I gotta round this off to two decimal places. So $161.81. Is that okay? $161.81. So far, so good. Let's take a look at number 6. Number 6. Oh, sorry. Number 6, it says here you keep your careful records of how much fuel your van uses and have determined that the fuel economy is 11.2 liters per 100 kilometers. Highway. And you are on a trip through rural Manitoba. You pulled into a gas station at 1 a.m. when your tank was almost completely empty. It took 71 liters of gas to fill it up. Determine if you will make it to the next gas station if the next gas station is 550 kilometers away. Okay, so how can we How can we figure this out? This is a fuel economy, 11.2 liters per 100 kilometers. And then it will take 71 liters of gas. So 71 liters. Liters are in the numerator, so we're going to figure out the denominator one. So again, we're going to cross multiply. So we're going to cross multiply here and cross multiply there. Cross multiply, so it's x times 11.2 equals 71 times 100. So we're trying to solve for x. We have to divide here by 11.2. 11.2 to cancel the 11.2 and isolate the x. Is everybody okay with this? Cross multiplication? Yes? Cross multiply. So the x crosses to multiply by 11.2. 100 crosses to multiply by 71. So that's that.
Don't make it.
And then we had to divide by 11 to solve for x. So x is equal to, okay, for that 71 liter of gas, it's gonna make us reach up to 633.93 kilometers. Okay. So with that 71 liter of gas, it's gonna reach 633.93 kilometers distance. Now if the next gas station is at 550, are we gonna reach it? Yes. Yeah. So yes, because the next gas station is closer than 633.93 kilometers. How did I get this part? So the first part that I did was to set it up. 11.2 per 100, so 11.2 per 100 kilometer. And then we know that we filled it up by, filled up the gas with 71 liters, right?
11.2.
So what we're gonna do is we're gonna cross multiply to solve for x. We're gonna solve okay, so solve for x and it.
That is real angle.
Okay. To do that, we need to cross multiply. So we cross multiply, the x will multiply by 11.2, so x times 11.2. And then the 100 will cross to multiply with 71, so right there. Now, we have to solve for x, meaning isolating the x, having it alone. So what we need to do is we need to divide by 11.2. So if you go 71 times 100 divided by 11.2, you're going to get up to 633. Okay, and that will make it, yeah, we'll make it to the next gas station. I think what I'm going to do is I'm going to stop right here. I'll give you some questions on the assignment. Okay, I'm going to stop right here. Stop there. And based on those things that we've talked about, I'm going to get you to, I'm chunking it out. Chunk it out. because this is going to be way too long to do it all at once. So for your practice question, I'm going to ask you to go to page 6 and to complete questions number 1 through 7. So just complete questions 1 through 7. So it's not too much talking. Okay, is that good? I'll leave that with you.